Hello friends, welcome back. So in today's session we will see class and object in Java programming language. In the session of object oriented programmings, we have already seen what is Java, what is object, how we can create Java, how we can create object. But all that point we have seen in the perspective of object oriented programming. But in today's session we will see from the perspective of Java object oriented programming. We will see the class and object in the perspective of Java programming language, and we will learn in this session how we can define a class, how we can create object, and what are the possible members of a class that you can define, and what the steps your JVM will follow to load the class, and what steps your JVM will follow to create the object. So all this point we will learn in today's session. So let's get started with that one. So as we have already seen, a class is a blueprint. A class is a blueprint of object, and the object is a real world entity. Class is a blueprint of object, and object is a real world entity. Or we can say that everything is object into this real world. Everything is object world everything is object in this world, like chair, pen, mouse, laptop, computer, mobile phone, persons, anything is object. So that points we have already learned. What is the state of object, what is the behavior of object, how we can define, all this we have already seen. But in today's we will learn what are the possible members. First we will learn what is the possible members of a class. In Java, class has some members we can define, and that is the valid member only. Other than that you cannot define anything in your class. Even you cannot define any single statement also. Directly some statement also you cannot define into your class. These are the valid statements only. These are the valid members only, not a statement. These are the members. So these are the valid members of a class. First one is a static variable. What is static variable? Static variable, it is a member of a class that is declared with static keyword. First, static variable has to be declared with the static keyword, and the value of static variable will be available for all the objects of class. Suppose one class is there. For that class, if you want to define some common value for all the objects, because definitely for one class object is required, or object will be created. For a class object will be created, and we want to define some common value for that object. Suppose for one class you can create 10 objects, or you can create 100 objects. It's up to you, or it's up to developer only. So suppose developer has created 10 objects for a class A. In that case 10 objects will hold their different values, but I want to give some common value among them for all them. Then how it is possible? In that case we have to give static variable. Means static variable is a shared variable for all the objects of class. So here if you see the definition, it is a static member of a class that is declared with a static keyword, and the value of a static variable will be available for all the objects of the class. Static variable can be accessed by class name or by the reference object. you can access static variable, you can access with the class name only. That is enough, because no object is required to access that variables. No object is required, and you should not access that object with the any reference variable. That is not recommended at all. But to access the static variable with the class name, this is called a static context, is a recommended only, and no object is required to access the static variable. Suppose why the object is not required? Because the memory of the static variable will be allocated inside method area. Now we will see where the memory allocation will be happen, for which variable memory allocation, where the memory allocation will happen. So suppose if your object if the object of a class is not created, in that case also that static variable will be created and that memory will be located for that one, and you can access that variable with class name only. You no need to create any object, because that is a shared variable, that is a common variable for all the objects, whether there is a one object or 10 object or 100 object, the variable will be common for all them. So that's why if it is a zero object also, then also that variable will be available. In that case, no object is required to access that variable, or no object is required to set the value. You can access, you can set with the class name only, and the recommended way is only the class way, only the class name, only the static context. You should use static context. Static context is nothing but accessing the static variable with the class name dot variable name, or class name dot some static method, that is accessing that variable. So that is the called static variable. Next one is instance variable. What is instance variable? Instance variable is not shared among the objects. Instance variable, each object will hold itself. Each object will hold itself. That is the instance variable. Means you can say that each object has their own instance variable and they have their own value. One object cannot change the instance variable of another object. That is not shared. That is the object's own variables. So suppose instance variable is not shared variable among the objects. Each variable has its own value for object, and the instance variable can only be accessed with object reference or with object reference. You cannot access that with the class name dot variable name, like that you cannot access. That is only be accessible with object reference only. Because why it is like that? Suppose for one object, there you have created one object, so definitely you can say that for that object only you need some values, and that is instance values only. Sorry, that is instance variable only. So that instance variable memory will be allocated for that object only. So definitely you have to access with that reference variable only. Otherwise there is no way that you can access any instance variable. Because instance variable is meant for objects only. We can say that we can say like that, static variable is meant for class, instance variable meant for object. Static variable value will be located inside class only, instance variable value will be located inside object only. So to access instance variable you need object reference, and to access static variable you no need any object, you can access with class name only. And the next one is a static block. So these two is the valid member of a class. These two are the valid member of a class. Third member is a static block. Static block is nothing but it is a block with a static keyword. It's a block with a static keyword that can be used to initialize the static variable. Static block is a block with the static keyword that can be used to initialize the static variable, or we can say that that can be used to initialize the class, that can be used to initialize the class. When we say initializing the class means initializing the static variable of a class, that's it, that only. How will you initialize? Initialize means you have to set some values only. How will you initialize the object value? You have to initialize, you have to set the instance variable value only. In that case only you can initialize. So we can say that static block can be used to initialize the static variable of a class, or we can say that static block can be used to initialize the class, and this static block will be executed before to loading the class. Suppose before to create a class, first object, before to create an object, class should be there, and after creating the class should be loaded into your JVM first, then only you can create the object. So first class has to be loaded, then object has to be created. But class loading will be happen only one time, because from one class you can create n number of objects. So class will be loaded only one time, but object can be created multiple times. N number of object you can create, but class only one time is required to load only, because that's a blueprint only. One blueprint is enough in your memory. From that one you can create n number of object. So that's why static block will be executed while loading the class, and it will be executed only once. It will be executed only once because class is loaded only once. One time it will be loading. Class will be loaded only once, and in that case a static block also will be executed once. So we can say that this the block with the static keyword to initialize the static variable of a class called a static block. It will before to loading the class, it will execute before to loading the class, or it will be executing into the second scan of a class. Yes, that we will see how your JVM will loading the class. JVM is following some steps to load the class first. We will see that one. It will be executed only once. Static block will be executed once because the class will load only once. In short, we can say that static block can be used to initialize the class. Initializing class is nothing but initializing the static variables. So static block can be used to initialize the static variable. Next is instance block. In the same way, static block can be used to initialize the static variable. In the same way, instance block can be used to initialize the instance variable. So, but instance keyword is not there. Static block, static keyword is there. We can use that one to differentiate. But for instance block, there is no keyword. Directly you will define one block that will execute when your object is creating, before to create the object. So instance block used to initialize the object. Yeah, why we are saying here object? Because instance variable is related to object only. Instance variable is related to object only. Static variable is related to class only. So instance block is used to initialize the object, or we can say that it is used to initialize the instance variable of the class. It will execute before to creating the object. Yeah, before to create the object it will execute every time. When you create object using new keyword, it will create it will execute every time. It will execute before to creating object, because it can be used to initialize the object only. Instance block will executed many times. It will be executed whenever a new object is created. So that is called instance block. So static variable, instance variable, static block, instance block. Next is the constructor. Constructor is also a valid is a valid member of a class. Constructor can be used to create the object. Constructor is used to create the object of a class, and along with that, constructor can also be used to initialize the object state. Object state is nothing but to initialize the instance variable of a class. If you want to initialize through constructor, you can do that one. If you want to initialize with static block, instance block, that also you can do. But what is the benefit if you want, what benefit you will get if you use constructor to initialize the value? Because while creating the object, you can define value. Yeah, I want to create object with this value, you can define that one. But in static block, you cannot do that one. In static block, you have to do in instance block, you have to do hard code only. That hard coded value always will be initialized. Or what you can do, you can use instance block, and using that instance block you can read some file, and inside that file you can define some values, and with that values your object will be initialized. That is up to your choice how you want to initialize. You want to read the file, whatever you want to do in that block, you can do that one. So constructor is the main feature or main use of constructor to create the object. And if you want to initialize the state of object, that also you can do. Constructor has the same name as a class name, and it is like a method only, but it doesn't have any return type. Constructor can only be used to create the object of class. You suppose there is no way to create the object other than constructor. Constructor only you have to use to create the object. Yeah, reflection is there. Using the reflection you can do, but reflection again, that will use constructor only. We will see that one. So constructor is used to create the object of a class, and along with that, if you want to initialize the state of object, that also you can do. So that is also a valid Java member. Static variable, constructor. Constructor is also a valid member of a class. Okay, next one is the inner class. Inner class is nothing but it's a class only, but inside a class you can define a class. That's called inner class only. Suppose, and both type of class you can define. You can define a static class, or you can define instance class. It's up to your choice, but that is a valid class. Inside class is a valid. Yeah, inner class is a class only, but declared inside a class. This can also have the same member that a class can have. Suppose same, it is a class, whatever the member in a class can have, in that class also the same member can have, or different member can have. So this is a class only. It can be declared with access modifier. Yes, using that access modifier you have to define, like you can define that class as a private, default, protected, or public, but the outer class cannot be declared as a private. That is very important. So far we have created so many classes, but we have always given public class name, public class student, public class person, public class employee, like that we have given. We cannot give private class private class person, private class student, private class employee, like that we cannot give, because top level class cannot be private. Then how will you create the object if it is a private? So that's why top level class you cannot give as a private, but inside a class you can give that class as a private, default, protected, or public, anything, whatever you want. So class inside class, that is called inner class, that is also a valid. Next is enum. Enum is also a valid inside a class. What is enum? Enum we will see in the next session. But what is enum, for your information I will tell. Enum is a data type, same like a class only. It's a data type. It can be used to define a static value as an object. Suppose some static value you want to use as object. Suppose like alphabet A. You can use alphabet A as a string. Inside a string you can define alphabet A, but You can use alphabet itself as an object. Alphabet is an itself is an object, but that object contain values only, one value only, a, but that you are using as an object. You can do that also. That is called enum. We will see in the next session this one. Interface, next is the interface. Interface is also a valid member of a class. What is interface? Interface, it is also a data type, same as a class. It defines the functionality without the implementation. Implementation you have to use separately. What will be the use of interface? That we will see in the next session. Why they have given interface in Java? There has some specific reason they have given like that. We will see in the next session, because in C or C++ some issue was there with inheritance. So for that, to remove that one, they have given interface. Along with that one, some extra benefits are also there that you will get when you use interface. So that's why they have given interface. We will see in the next session. Next is the method. Method is also valid in Java class. Suppose, what is method? A method is nothing but a function only. You can say function and method is same only. It is a named block. Yeah, method has a name, that's why it is a block only. It's a block only, but that block you will give some special name. So we can say that is a named block that can be executed many times with object reference. You need object that for that one. And it is not like that that method can be instance only. That can be static also. You can define static method. If it is static method, then you can use with the class name. Same thing. It is used to operate on variables, on the variable of a class, and to implement the behavior of object. We have seen this one. What is the behavior of object? That you can implement through the methods only, and that can also be used to implement the polymorphism concept of object oriented programming. Method can be used to implement the polymorphism concept also, and that can also be used to implement the behavior of an object, or you can say that it is used to operate on the variable of a class. And polymorphism, how you can achieve in using these methods? By changing the number of parameters. Suppose method name, see here we have seen the named block. The name will be same, but you will change the parameter, you will change the number of parameter. Like in one method with the same name, you are giving one parameter. In the second one, you declared another method with the same name, but you have changed the parameter number. Like in the first one you are giving one parameter, in the second one you will give two parameter, third one you will give three parameters. So you can change the number of parameters. In that case also you can implement the polymorphism. Same name, behavior is different, and you can change the order also. Suppose first one is a string, second one is an integer. In the next one you can give first one is an integer and second one is a string. It's up to your choice. In that case also it will behave differently. And you can change the type also. Suppose in the first one, same method with one parameter, that is a string, and the same method you can declare with one parameter, that is integer type. That is also fine. You can define in that way. So these are the three ways you can achieve polymorphism: by changing the number of parameter, by changing the order of parameter, and by changing the type of parameter. So that is also valid. Method is also a valid member of a class. So we can say 1 2 3 4 5 6 7 8 9, these 9 members is the valid. This 9 member is valid for Java class. Okay, so we will see one example here. I am opening this class A. Inside this class, suppose we have created a public class. See, we have defined top class cannot be private. I cannot give this one. Sorry, private. You cannot give this one. If I give here, compiler itself will give error here. illegal modifier for the class A. Only public, abstract and finals are permitted. You can give public, you can give abstract, you can give final, or is permitted only. Private you cannot give. So we are giving public here currently. We will see this one. We will see access modifier. What is the use of public, private, protected, all this we will see. So we have declared one class, public class A, and inside this class we have declared two variable. First we have declared two variables. First one is a static, that is a byte of f1, field 1, that is a static type, and field 2 is a instance type. We have seen already here. If we see the definition, static variable means defined with a static keyword, that will be defined with a static keyword. Yeah, we have used here static keyword. With this static keyword we have defined f1, that is a static, means that is for class level, and another one is a private, that is for object, and static block that can be used to initialize this f1. Yeah, see, we are initializing f1. Inside this static block we are initializing. First we are printing what will be the default value. Default value will be 0. After that one we are initializing inside the static block, and inside instance block we are initializing f2 is a instance variable. So instance block, this is instance block, this is instance block, this is a static block, this is static block, this is instance block. So we have declared two variables, one static variable, one instance variable, and we have declared two block, one static block and one instance block. So using static block we are initializing static variable, using instance block we are initializing instance variable, and we have declared constructor. Using this constructor, this is a default constructor, we are creating this object. If we are creating object with byte, then we are initializing with this value. And so this is a constructor. Constructor, what is the definition? If we see what is constructor, yeah, constructor, see here, constructor can also be used to initialize the object state, and constructor is used to create the object. Along with that, constructor can also be used to initialize the object state. So the same thing we are doing here. This is the constructor. With this constructor we can create object, and along with that one we can initialize the value of f2 also. Using this constructor also we are creating object, but we are not initializing the state of object. We are not initializing f2 value. See, inside this constructor, inside this constructor, line number 34 to 36, we are not initializing f2 is only the instance variable, so we are not initializing here. But inside this constructor we are initializing with this value, so we can do that one. So we have defined this constructor, these two constructor here, and constructor has the same name as a class name. So class name is a class 1 and constructor name is a class name class A. It doesn't have a return type. Yeah, it doesn't have a return type also. So this is a constructor. If you see the definition, constructor has same name as class name. It is like a function only, but don't have a return type. But constructor can only be used to create the object of class. So same thing, constructor, it doesn't have a return type. It is the same name as a class name, and it is used to initialize the state of object. So this is the constructor. Next one is enum. Enum is also, we have already seen what is enum here. Enum we will define in the next session, but from your information only, it can be used to define a static value as an object, static values as an object. See here, these are the static value a, b, c, d, all are alphabets, but I want to use this as an object. You can do that one also. So in that case we have defined enum here. Next one is in interface. Interface is what? It will define the functionality without the implementation. That is the definition only. It defines the functionality without the implementation. See, functionality is there. Public void method m, method 1. This is the functionality only. What you want to do in this method 1? You can do anything. We will see this one, that implementation, how it will be. So this is the interface. That interface is also valid. And here we have defined one inner class, that is a static. See, if you see this inner class, this is also has a private one instance variable, and it can have a static variable also, no issue. And this is the constructor of that class, and this is the toString method. So this is looking like a class only, but this class is present inside this class only, and that is a static. We have declared this is a static, and you can declare non-static also. See, this is a non-static inner class. This is a class, public class inner class B. Yes, this is an inner class B. This is inner class A, inner class A, inner class A. This is inner class B. So this is a class only, class inside a class called inner class. So that is also valid inside class. You can write that also. And these are the some methods. So these are the methods. These are the methods. Methods we have already seen the definitions. It is nothing like, it's a function only. It's a named block, and that can be used to operate on the variables of a class and to implement the behavior of object, and it can also be used to implement the polymorphism. So that also we have, we can write that also if you want to see in the separate class we will create, and we will see this one. Okay, so these all are the valid member of a class. Variables, methods, these are the methods 1, 2, 3, 4, 5. These 5 are methods. Class, methods, inner class, interface, enum, constructor, static instance block, static block, and static and instance variable. So these are the valid member of a class we can define, and in this way we can create the object. In this way we can create the object. Suppose, yeah, so here, so now so we have seen this examples here. So next thing, memory allocations. We have to see the memory allocation also, how the memory will be allocated. See, in your JVM, memory will be divided in this 3 parts. Memory will be divided into 3 parts. One part is called a method area, one part is a heap area, and one part is a stack area. What is method area? Inside this method area, your class will be loaded. All the classes will be loaded. All the classes will be loaded. Classes and the static variables will be loaded. Inside method area, all the class and the static variable of a class will be loaded. Means you can say that the memory allocation for class and static variable will be allocated inside method area. And heap area, the object of a class is loaded and the instance variable of object is loaded. Suppose inside heap area, your object will be, the memory of object will be allocated. You can say, we can say that inside heap area, object, the memory for object and the memory for instance variable will be allocated. And what about this stack? Inside this stack, your method will be executed. Whatever, so their method is also a part of stack only. So that method will be executed in stack area, inside stack area. And the memory of local variable means whatever the variables that you are using inside whatever the variable that you are using inside method, that is a local variable. Means any new variable you are creating inside object, inside method, that is called a local variable. Then local variable memory also will be located inside stack area only. Okay, so this is the memory structure. This is the memory allocation structure in JVM. How your inside method area, your class and static variables will be stored. Inside heap, your object and instance variable will be stored, and inside stack your methods and methods local variable will be stored. Okay, and what steps your JVM will follow to load the class? How your JVM will load the class? Suppose inside this method area, before to create any object, your class has to be loaded first. Before to create any object, class has to be loaded first, and class will be loaded only once. So your JVM has to load the class. Then how it will load the class? There are some steps that JVM follow to load the class. The class will be scanned twice to load. 2 times your JVM will scan your class. Suppose how in the first step, what your JVM will do? In first scan, JVM scans all the static variable of a class. All the static variable of a class. Inside your class, if you some static variables are there, then your JVM will scan that one, and allocate memory for that variables into method area, and initialize them with the default value. This is very important. You have to understand. We will prove that also. See, in the first scan, your JVM will scan all the static variable of a class and allocate the memory for that variable into method area, and the memory will be allocated according to their types. Suppose if it is an integer, then memory accordingly it will be allocated. If it is a string, then according to that type only memory will be allocated. That we will see data types in the separate session. We will see data type and with the memory, how much memory it is taking, like that. Next, in the second step, this is the first step. In first step, your JVM will scan all the static variable and allocate the memory inside method area, and initialize that variable with the default value, In second scan, JVM will scan all the static member. Here it will scan static member of a class in the same order how they defined into class. Suppose first you have inside your class, first you have declared one variable, then you have declared one static block, then you have declared one static variable, like that. Suppose if we open this one, here we have declared one static variable, and then we have declared another instance variable, that in that case, and then we have declared one static variable. So this is the order. First one static variable, then one static block. If after this static block we have declared one static variable, so that will be scanned after, because before this static block will be executed in the second scan. So in second scan, your JVM will scan all the static members. Static members means that can be a static variable, or that can be a static block. So your JVM will scan that one. Of the same class in the same order how they are defined into class. If the static member is a variable, then JVM will initialize that with actual value. What is the actual value? Suppose I am giving this value as 100. So this is actual value. This is your actual value for this static variable f1. Actual value is 100, but your JVM, what your JVM will do in first scan, it will initialize with the default value first. First it will initialize with default value. In the second scan, your JVM will initialize with your actual value, whatever actual value you are giving, it will do. And if it is a static member, if the static member is a static block, then JVM will execute that one. Suppose okay, suppose here this is how I am giving, this is a default only. I have declared one variable here, that is a public, okay, for simply I am just giving, and I am giving this temp test. Simply I can give anything, and actual value I am giving as an 110, that one. So see, so in first scan, your JVM will scan all the static variable. All the static variables means it will scan for F1, field F1 and field temp state, and your JVM will initialize with the default value. What is the default value of F1 is 0, and what is the default value of temp1? 0. So your JVM will initialize with 0 both. In the second scan, your JVM will initialize with this 110 to this temp test variable. So that is that point want to say in the second step. Okay, where it went? Okay, so in the if first okay, in the second scan, if you JVM found first variable is coming, then it will initialize with initializing value. If your JVM found that first in the first order static block is coming, then JVM will execute that one, and inside this static block you can see that whether the default value what JVM is initialized, that you can see that also. The class will be loaded only once. If the class is already loaded, then your JVM will not load it. Yeah, that's we have already discussed that point, because class will be loaded only once. So loading the class, the Java class can be loaded in these cases. In these many cases you can load the class. How? Suppose yeah, so you can load the class when the object of a class is created. When the object of a class is created, suppose if you see this code, we are creating object here, and I'm just running this code and you will see. So if you see here, we have not written any SOB statement, but this statement is executing. So this is a static block, static block of person. This is a static block of student, because student is inheriting person. In that case, your person class will be loaded first. If it is an inheritance relationship, in that case your super class will be loaded first, then child class will be loaded. So here if you see, if I open this student class, inside this student class I am extending person. In that case, person class first will be loaded. First person class will be loaded, and then student class will be loaded. So inside, if I go inside person class, then we can see inside person class I have declared one static block and one instance block we have created here, and inside student also we have declared one static block and we have declared one instance block. We have declared both. So inside student we have declared one static and instance block. Inside person also we have declared static and instance block, and inside this main class we are creating the object of student class. In that case, first person class object will be person class will be loaded. So person class static block is executing. Then student class static block will be executed, because after loading this person, your student class will be loaded, because person is the super class and student is the child class. So person is the parent class and student is a child class. So first parent class will be loaded. After loading this parent class, student class is loading. After that, one object is creating. So it is before to create this student object, first it is creating the object of person also. So first person instance block is executing, then student instance block is executing. So this is the one way that you can load the class. And see how when the class will be loading the class can be loaded in this case when the object of class is created, and when any static member of a class is accessed with static context. Suppose this is the static member of a class and we are accessing it using static context. See, inside student, if I open this student class, you see student sfv1, one variable is there, that is a static and that is a public, that is a static and that is a public. So that's that static variable I am accessing. In that case also your class will be loaded. Yeah, you can see this class is loaded, but now object is not created. Why? Because we are accessing the static variables only. We are not creating any class here. We are not creating we are not creating any object here. Just we are loading the class. We are just accessing the static variable, and when we are accessing the static variable, your class will be loaded, because this is the case here. You can load class by accessing any static context also. And the third one, when the static member of a class is accessed with a null reference variable. Null reference variable, how? Suppose I am commenting this statement. Next one, this one. I am just setting student dot sfv1 to null. In that case also your class will be loaded. Person and student, yeah, class is loaded. And if you can load the class explicitly also in this way. This is the explicit way of loading class. How? Class one class is already inside your JDK. Using that class you can give the class name, fully qualified class name. This is fully qualified class name. Your JVM will load that class. You are telling, yeah, please load this class. You can load that in that way also. So in this way also you can load your class explicitly. So there are four ways that you can use to load any class. You can simply create the object of a class. Your class will be loaded. You can access any static member of a class. That can be a method also, or that can be a variable also. In that case also your class will be loaded. Or if you can access any static variable with a null reference, in that case also your class will be loaded. Or explicitly also you can load by dynamically. You can use this class.forName. In that case also your class will be loaded. Okay, suppose here we have defined we have said something here in this first step. In the first scan, JVM scan all the static variable of a class and allocate memory for that variable into method area and initialize with them default value. How will you prove that one? And in the second run, in the second scan, your JVM will initialize with actual value. In first scan, your JVM will initialize your static variable with default value, and in the second scan your JVM is initializing with actual value. How will you prove that one if we want to do that one? Suppose inside this student we have defined this variable. I will define this variable here. I will define this variable after this static block, and this is a static variable, and one more variable I will give, that is a instance variable. It is a not static variable. Okay, that is also string. Static field, this is a instance field. I can give ifv1. S for static, F for field, V for variable. 1 is 1, that's it. Static field variable 1, and I stand for instance field variable 1. That's it. Okay, so this is static field. This is here I am giving some other value like hello, and here I am giving hi. Okay, and inside this main class I will use this first step only. I will use this only. Okay, I will just create that object. I will just create that object, and inside this student I can declare one toString method. Okay, fine. toString generate toString. Yeah, generate toString. So okay, toString is generated. That's fine. And suppose I want to verify in first scan your JVM will initialize with default value SFV1. We have said here in the first scan JVM scan all the static variables of a class and allocate the memory for that variable into method area and initialize them with default value, and in second scan your JVM is initializing with actual value. How will you prove that one? So that only we want to prove here. Suppose in first scan your JVM will scan this static variable and your JVM will initialize with default value. Default value is null. Default value for this string type is null. So, and in the second scan your JVM will scan all the static member in the same order. In that case it means your JVM will scan first static block only. Inside this static block, if I print this one, then definitely I will be able to see the value what JVM is setting in first scan only. So system.out.println to what? I will print this one, this variable. Okay, but you cannot access like that. It should be before only. In that case you have to use this class name. You have to use class name only. Okay, yeah, that's fine. You can use that one because that is the recommended. That's why it is a recommended way. That's why it is a recommended way. So student.sf1 we can use because it is a static variable, and inside instance block I can print this instance variable, but instance variable you cannot access with class because object needs to be created. Where is that object? You can access in this way. This is the use of this super, that keyword we will see in the separate session. Currently you just see this, I am printing this variable only. So okay, that's fine. Now what the result, if you see what result I will get when I will create the object of a class of the class of student, and I will print that one. Suppose I am printing here, you will see some magical things here. Suppose and sys system.out.println student, okay, student dot, okay, student dot wait, both are private, both are public only, fine. So student dot ifv instance variable I am printing, and here I will print the value of static variable. Okay, so this is a static variable, value, and this is instance variable value that I am printing here, So first I am creating here student. In that student I am printing here what is the static value, of student sfv1, and what is the instance value. And if I run, you will see some magical thing here. See, what is the value of student sfv1 hello, and what is the value of ifv1 hi. But inside block, if you are printing, that is null only. Why? Because your JVM in first scan, that value, that variable is initialized with the default value only. In the second scan, that is initialized with actual value. So that is called the that is the steps that JVM will follow to load the class. And what and how you can create the object. Okay, we have seen this way of loading. And how we can create the object? We can use use constructor. See here, type is nothing but a class. You can give any class, any reference variable, new keyword you have to use, and you have to use this class name, and this is the constructor. Constructor can have n number of parameter also. That can be a no parameter, 1 parameter, 2 parameter, 3 parameters. That is up to the requirement only. We have declared 1 constructor, 2 constructor, like that we can give. So this is type is nothing but a class. So this is the example of this one only. This one, student is equal to new student. We have created in this way student. So here also this is telling type only, whatever the type, student, person, anything, that you have to give that class. Student type is nothing but a class. Class, whatever class you have given, that name only. And the reference type, any variable name. New keyword you have to use, and you have to use the same class and with the constructor. So this, in this way you can create the object. Creating the object, the following are the syntax to create the object only. Next one, JVM steps to create the object. See, in the same way how JVM is creating loading the class, in the same way JVM is following 2 steps to create the object also. In the first scan, what your JVM will do, your JVM will scan all the instance variable. In here, in this, while loading the class, your JVM is scanning all the static variable, but inside while creating object, your JVM is searching for all the instance variable and allocate memory for that variable into heap area. Here you see, here the memory location will happen inside heap area, but here the memory location will happen inside method area only. This is a method area. Inside this method area, all the classes and static variables will be loaded. Inside heap area, all the objects and instance variables are loaded. Means the memory location will happen for object and instance variable inside heap area, and the memory location for static variable or class will be happen inside method area. Inside stack area, your method execution will be happen, and the method local variable will be stored. Okay, so while creating object, first in the first scan, your JVM scan all the instance variable and class and allocate memory for that variable into heap area and initialize with them default value in the same scenario, like while loading class, default value. In the first scan, definitely your JVM will initialize with the default value only. In the second scan only, your JVM will initialize with this actual value, and the order, your JVM will follow the order. How exactly order? If first one block is coming, then JVM will execute that block only. After that one, if your variable is coming, then only your JVM will initialize that variable with actual value. So that we have seen in this example, because we have declared these variables after the static or instance block. After the static or instance block, we have declared these 2 variables, and that result we can see. If we print here, we will get null. See, you are getting null. Static variable also we are printing, that is null. This is also null. Sorry, I think we have wait. Yeah, static. Okay, that's fine. Static only. That is instance variable. That is static variable only. That only. Yeah, that is instance variable, that is also null. Static variable also null, because in first scan your JVM has initialized with the default value, in the second scan your JVM has initialized with actual value. So that is the that we have proven here, that we have proven that whatever the JVM, your JVM is following the steps. Okay, so so that is all about this one. Okay, and inside this class A, we have declared all the fields, all the members. We have declared all the members. So these 8 types: static variable, instance variable, static variable and instance variable, static block and instance. So remove this one, that's not required. Okay, see, so what are the valid member of a class in Java? Static block. Static block is a valid member. Sorry, not a static block, static variable. Static variable is a valid member of a Java class. Instance variable is also a valid member of a class. Static block is a valid member of a class. Instance block is also valid member of a class. Constructor is a valid member of a class. Enum is also a valid member of a class. Interface is also a valid member of a class. And inner classes are also a valid member of a class. And along with that, methods also you can declare inside class. So these are the valid member of a class: static variable, instance variable, static block, instance block, constructor, inner class, enum, interface and methods. So these are the valid member of a class. So how we will use those, we will see now. Suppose inside this class we have declared all the variable, all the possible members we have declared inside class A. Inside this class A, all the possible member of a class we have declared, and we are going to use inside this class A main class .java. Inside this one we are going to use. Suppose first we are creating the object. Yeah, as that is same how we were creating the object for object of that class. In the same, that is the way only to create the class, to create the object of class. Class A, this is the reference variable. New, this is a class A, this is a constructor that we are using to create the object, and just we are printing here. That is very common. Here, see, here inside this class A, one inner class is there. That is inner class A, and inner class A is a static class. Inner class A is the static class. Yeah, see, this is a static class. So for that inner class A, how will you create the object? So this is the syntax of to create the object for that one. Class A dot inner class A and reference variable inner class A, new class A dot inner class A with the constructor. You can use, because we have defined this constructor inside inner class A. So this is the way to create the object of static inner class. And if it is instance inner class, then how will you create? There are two ways to create that one. Suppose one is, because object is required for that one, to create the object of non-static inner class or instance class, you need the object. Object we already have class 1. So using that class, see, class A dot inner class B is equal to class A. This is the reference variable of a class A dot new inner class B. Inner class B is what? Inner class B is inside inner class A. Inside class A, one class is there, that is in inner class B, that is a non-static. It's a not static. That is instance class. So class A dot inner class B, class A reference variable dot new inner class B with this hello. This is the one way to create. and if you don't want to create this one, you can create that object here also, that is also fine, but it will be create new class, it will be create new object, sorry, you can do in this way also. Class A dot inner class B new class A constructor dot new inner class B constructor, you can create in this way also, that is up to you. Means you don't want to create another object from the existing object, you can create, or you can create instant new object, and in that object you can create a new inner class. So this is the way to create the object of non-static inner class. Next one is anonymous class. Why anonymous class is required? Because our interface is there, and interface we have already seen, it is giving the functionality without implementation. If it is not implementation, then where the implementation will exist? Implementation will exist inside implementation only. So this is the implementation, this is the default, this is the inner class, sorry, this is the anonymous class. Anonymous class is what? The class that does not have any name, called anonymous class. And the anonymous class will be the direct subclass of this my interface. See, inside class A we have defined one interface, you see, public interface, my interface with method 1, that's it, we have defined here. So we have to implement that one, because this is an interface, we have to implement, and we have implemented that interface here only. So this is the subclass of my interface, and we can say that this is an anonymous class for my interface, and we have given the implementation for method 1 here, method 1 of my interface, that's it. So this is anonymous class of an object for my interface of a class. Okay, and the next one is enum. Last one is enum. Enum also we have declared in that class. So how we will access that enum? Class A alphabet A, class A alphabet dot A, that's it. Inside class A alphabet is there, alphabet is nothing but an enum. So this interface and that enum we will see in the next session. In the next session we will see thoroughly what is the use of interface, what is the use of enum, why they have declared, we will see in the next session. So currently you just see this is the member of a class. Here also you observe this is the member of a class, and that has to be created, and we have to see the object of that one, we have to see the use of that also. So that's why we have created here anonymous class, and we have and I have shown you the use of that one, how we can use that one. And this is the alphabet A. Now you see enum is what? Any value, any single value you want to use as an object, that you can do. See, here is an alphabet A only, but that alphabet A you want to use an object, you can use that one also. So that is an example of enum. If I run this one, and you will see the output. See, this is the output. Suppose first one, creating the object of A, it's creating the object before loading class A. Static block of class A is executing before to load the class, and F1 value is 0, and before creating the object of class A, instance block of class B, and F2 is the instance block. F2 is an instance variable, F1 is a static variable. So, and after that one I am printing the static variable F2 is a static variable, that value is 16, and F1 is a instance variable, that value is 50. But this is the default value that is initialized. This value is initializing inside static block. F2 is the static variable, F2 is instance variable, F1 is static variable. So this variable value is a default value, this is the default value, this is the value after initializing inside static variable, this value is the default value, this value is after initializing inside instance block, and this is the output of inner class A, this is the output of inner class B, this is the output of that anonymous class, and this is the output of enum. So in this way we can define the member of a class. We can define these many members inside a class. So in today's session we have learned what are the valid member of a class. So these 8 1 2 3 4 5 6 7 8 9 1 2 3 4 5 6 7 8 9. So these nines are the valid member of a class that you can declare, and we have seen the example also. We have declared all those, and we have seen the definition. We have seen the definitions of each them, and we have seen the memory allocation also, how the memory will be allocated for object, how the memory will be allocated for class inside your JVM, and how your class is loading and how your object is creating. So all that we have seen, and how we can create the object, and in which case your class is being loaded. So we have seen already, we have seen all that. So in the next session, what we will see, in the next session we will see enum interface, enum interface and annotation, because interface is also a data type, enum is also a data type, and in the same way annotation is also a data type in Java. But annotation is has a different use. Annotation has a different use that we will see in the next session. What is the use of annotation, why we need annotation, all this we will see in the next session. So I hope you like this today's session. So please subscribe my channel, and thanks for watching, and we will see you in next video. Till that, bye bye.